Augustin-Jean Fresnel was a French physicist known for his work on wave optics. Fresnel was born in 1788 in the northwest part of France, a year before the French Revolution began. His father was an architect, and both his parents practiced Jansenism, a Roman Catholic reform movement that said people couldn't do much to affect whether they went to heaven or not. This pessimistic view of human nature meant Fresnel grew up in a strict household that gave him the discipline he had throughout his life. Fresnel's parents taught him during childhood, but their efforts were not very successful, as he struggled with reading even by age 8 and showed little intellectual talent. However, once Fresnel went to the Central School in Caen at age 12, he demonstrated skills in math and science. Deciding to be a civil engineer, he went to the Polytechnic School in Paris and then the National School of Bridges and Highways. The Bridges and Highways Corps then hired him to work in the government departments of Vendée, Drôme, and Ille-et-Vilaine, building roads. During this time, he did light experiments whenever he could. An interesting thing is that Napoleon was trying to conquer France in this period. Since Fresnel supported King Louis XVIII and the rest of the monarchy, he lost his position when Napoleon returned from exile, which gave him more time to work on his experiments, even though he probably wasn't that happy about losing his job. But after the second restoration of the monarchy, Fresnel became a civil engineer in Paris and later a secretary for the Lighthouse Commission. And you can see in this slide there's a picture of the logo of the Polytechnic School in Paris, as well as a portrait of Napoleon and a picture of a lighthouse, which happens to be the same colors as the French flag. Now, Fresnel was unusual in that most physicists at this time believed in the corpuscular theory of light, while he did not. This theory by Isaac Newton said light behaved as particles. Fresnel, on the other hand, believed in the wave or undulatory theory of light, which said light moved as waves. He was important because he provided much support for the wave theory using math formulas and lab work, and he developed a theory of diffraction. He also was the first person to prove that light waves have transverse motion, which means that their path is 90 degrees perpendicular, and they can travel through a vacuum and resemble a sine function. To demonstrate light interference without diffraction for the first time, Fresnel used two black mirrors and showed that they had alternating dark and light bands. Later, Fresnel showed how people could get circularly polarized light, which means a type of perpendicular electromagnetic wave, as modeled by the pink picture in the corner. Fresnel also made what we call the Fresnel lens for lighthouses. They are still in use in some places today. When Fresnel made them, they worked much better than the mirrors people were flashing before, since the mirror light became weak in storm conditions, which is obviously not very helpful when you're trying to navigate through bad weather. So the Fresnel lens is made out of many concentric glass rings, which are glass circles that have the same center, as well as triangular prisms, and these two things together help to concentrate the light in a powerful beam that can reach for over 20 miles. Later on, Fresnel's paper on diffraction won him the Grand Prix from the Académie des Sciences, which is the Academy of Sciences, in 1819. One of the judges, Siméon Denis Poisson, said his theory meant there should be a light spot in the center of a shadow cast by a round object, and when another scientist proved that that was actually the case, the committee took it as confirmation of Fresnel's work. Fresnel became a member of the prestigious Académie des Sciences and the Royal Society of London. He won the Rumford Medal, as depicted in that picture of a coin-like object there, for his contributions in wave theory and optics the same year that he died. Fresnel died of tuberculosis at age 39, and he remained religious throughout his life. And before he died, he said that discovering the truth was more important to him than becoming famous. What's important about him is that our modern quantum theory of light, which says light sometimes behaves as a particle and sometimes as a wave, would have had difficulty replacing the corpuscular theory that was exclusive to physicists at the time if it weren't for Fresnel's evidence for the wave theory. Because of the scientists, we also know many properties of light that help us build technology and manipulate diffractions, refractions, and the like. And Fresnel's work inspired modern lighthouse technology, saving many lives along the way.